Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Tuan Muhammad Syahmi bin Tuan SAHA'ARIF. Today I will present my FIP1 interim presentation. And my FIP title is Air Conditioning System, Automatic Remote Control with Comfort and Energy Consumption Monitoring using Bluetooth Wireless Sensor. My supervisor is Dr. Muhammad Fazli bin Hanif. My co-supervisor is Madam Nur Zalina bin Haji Osman. My student ID numbers is 5421211708. And I'm from Bachelor in Mechatronics. Introduction. Malaysia is the third highest country in energy consumption within ASEAN. I got this statistic from Suruhanjaya Tenaga Malaysian Energy Statistic Handbook 2018. As we can see, the blue colors is electricity consumption. As we can see, 1996, the electricity contribute 15.9%. Okay, and this one is 2016. As we can see, electricity consumption for this year is 21.7%. In 2016, household contribute 14.1% of 12,416 keto electrical consumption. Keto is the unit for the energy consumption in this statistic that I got from Malaysian Statistic Handbook 2018. The world population exceeds 7 billion in 2011 and is predicted to be more than 9.3 billion by 2050. Increase in population will increase the energy consumption. Based on this statistic, the energy consumption increase every year. Based on Sustainable Energy Development Authority, SEDA, Malaysian mostly use electrical appliances in household along with the typical usage are as below. This is a few electrical appliances that in household typical usage. Okay, for example, this is a refrigerator. As we can see, for the cost of the electrical consumption, 95 ringgit a year. And for the table fan, we can see for 5-star rate to save ringgit per year. And if the house have 6 unit of the 5-star energy fan at home, you save 62 ringgit a year. Okay, this is television. For the year, we got 73 ringgit a year. And the highest one is air conditioning, which is 277 ringgit a year. So as we can see, the air conditioning are the highest electrical consumption. Electrical consumption. Uh, Increasing heat exposure level are one of the most certain effects of climate change. And there is strong evidence of negative health impact of environmental heat. Air conditioning system is promote as an effective solution to reduce heat stress and protect from heat exposure by providing indoor thermal comfort to avoid heat-related health problem. In 2000, in 2018, approximately 4.4 million air conditioners were produced in Malaysia compared to 4.2 million in 2017, which as we can see, the numbers of production of the air conditioner uh, is increased uh, due to this statement, which is the electric consumption increase. The intense use of aircon system have potential negative impact on both climate change and the environment in terms of carbon dioxide emission, especially if the energy source came from coal burning to generate electricity. Due to this, it is important for the aircon system to operate without unnecessary waste electrical energy while still providing good comfort to the occupant. According to this statistic, the power consumption in Malaysia increased annually. Due to this, some improvement need to be done on the current air conditioning system remote control. From the statistic that have uh, got and I read the statistic, we come up the problem statement. The problem statement first, conventional aircon remote control are unable to monitor the actual comfort level of the building and the electrical energy consumption of the system. Knowing the actual comfort and energy consumption is necessary for user to come up with the strategy to use the air conditioning system economically. Second, conventional aircon remote control only able to control the system based on set point temperature instead of comfort. Since comfort is affected by several parameters, the user-defined set point setting may not produce good comfort to them. In example, setting the temperature to low to feel very cool instead of feeling natural or slightly cool. This will lead to unnecessary energy usage. Okay, third, current aircon air conditioning remote control can only control the set point setting manually by the user. So the system cannot adapt to the environment change, which affect comfort automatically, causing discomfort maybe waste of the energy. Objective for this project is to develop thermal comfort index and energy consumption monitoring framework for air conditioning system by using Bluetooth communication to develop a comfort-based air conditioning remote control for comfort breaking with battery control algorithm. To integrate comfort-based air conditioning remote control with the comfort energy monitoring system for automatic control of the air conditioning system. Scope and limitation for this project is the project aim to develop a comfortable air conditioner remote control equipped with a convenient energy consumption monitoring system using an Arduino controller. Predicted mean vote PMV is the comfort index that will be used in this project. One of the PMV variable, which is velocity, will be considered constant. Another one of the variable, which is means radiant temperature, will be assumed to be the average of outdoor and indoor temperature. This is done due to complex measuring and this is done due to complex measuring method. The energy consumption monitoring will be done by estimating using coefficient of performance (COP) model instead of manual measurement to ensure simplicity of the system. Comfort index. We usually we have two comfort index that will be considered in our project, but I will discuss first about IAQ, indoor air quality. Indoor air quality IAQ is the air quality within and around building and structure. IAQ can be affected by gases, including carbon monoxide, radon, volatile organic compound, particulate, microbial contaminant, mold and bacteria, or any mass of energy stress so that can induce adverse health condition. This IAQ rating index, we have five index. The first one is excellent, good, fair, poor, and inadequate. This is temperature uh, for the measurement of the IAQ. For the excellent, 18 until 21 degrees Celsius, and this for the good, plus or minus 1 degree Celsius. This one plus or minus 2 degrees Celsius, per plus or minus 3 degrees Celsius, and in a decade plus or minus 4 degrees Celsius. This is for carbon dioxide. Relative humidity, carbon monoxide, nitrogen dioxide, EVOC. Okay, for the second one is PMV, predicted mean vote. The predicted mean vote PMV was developed as an empirical fit to the human sensation of the thermal comfort. It was later adopted as an ISO standard. It predicts the average vote of a large group of people on the 7-point thermal sensation scale, where cold, cool, slightly cool, neutral, slightly warm, warm, hot. For the cold, -3, cool, -2, slightly cool, -1, neutral, 0, slightly warm, +1, warm, +2, hot, +3. PMV is a one value comfort index which calculate using six parameters where air temperature is a measure of how hot or cold the air is. It is the most commonly measured weather parameter. Mean radiant temperature (TR) is defined as the uniform temperature of an imaginary enclosure in which the radiant heat transfer from the human body is equal to the radiant heat transfer in the actual non-uniform enclosure. Metabolism rate used to describe all chemical reaction involved in maintaining the living state of the cell and organism. Clothing insulation is the thermal insulation provided by clothing. Relative air velocity is the absolute value of the differences between walking and wind speeds. Relative air humidity (RH) is the ratio of the partial pressure of the water vapor to the equilibrium vapor pressure of water at a given temperature. British Thermal Unit (BTU). It was first used in the late years 1800s and has since become one of the most common units of classification in heating cooling appliances. BTU is used as a unit of classification in air conditioner, heaters, solar hot water heating fuel, cooking device, gas fire pits. Typical BTU range air conditioner are as follow. Uh, for portable air conditioner, usually 8,000 until 12,000 BTU. Split system air conditioner 9,000 until 36,000 BTU. Window mount air conditioner 3,000 until 25,000 BTU. 1 BTU is the energy needed to heat or cool the pound the or cool 1 pound. Is it means 0.45 kilogram of water 1 degree Fahrenheit. 1 degree Fahrenheit means 0.56 degrees Celsius at the sea level. One air conditioner tone equal to 12,000 BTU per hour. Air conditioning system power consumption. We have two measurement or estimation through calculation. For the measurement, we have pro and con, and for the advantage, this advantage is accurate, but this is have disadvantage. This advantage is costly and use most space because this instrument is too big. For the estimation through calculation, advantage simple and saving space, but uh, it have disadvantage. This is an inaccurate, means not accurate. This is the formula for the calculation. Literature review. I got and I read 9 articles. For the first article is automatic control system for thermal comfort based on predicted mean vote and energy saving. This is in this research paper have PMV is use a PMV parameter, And this article also discuss about automatic control. And for the second article is titled design of a control system for a fresh air conditioner. Is it discuss about IAQ? The parameter IAQ is measured in this research paper is carbon dioxide, and is discussed about automatic control and mobile apps. For the this research paper, this article, uh, this discuss about PMV. This in this journal is assume air temperature and air velocity. Next, uh, journal. Next journal is PMV, based fuzzy algorithm for controlling indoor temperature. This for the this journal is assume body metabolic, clothing thermal resistant, mechanical work done, radiant temperature, and wind speed. Next, a design of fuzzy controller for the conforming to the regulation of indoor air quality and thermal comfort. This is discussed about IAQ, parameter that discussed in this journal is carbon dioxide, formaldehyde, temperature, humidity. Next journal is an IoT-based smart controlling system of air conditioner for high energy consumption, energy efficiency. Uh, this is discussed about power, automatic control, and mobile apps. Study on indoor environmental comfort based on improved PMV index. Discuss about PMV. This journal is the writer or researcher calculate the average radiant globe temperature restriction, means radiant temperature. Next, development of low-cost device for monitoring indoor air quality in large-scale hospital. It discuss about IAQ. This which parameter that we discussed in this journal is temperature, humidity, carbon dioxide, volatile organic compound, ethanol, alcohol, carbon monoxide. PMV based genetic algorithm for indoor temperature control system. This is discuss about PMV. Also discuss about power. Analyzing air conditioning load based on comfort. Discuss about PMV. They assume metabolic rate, clothing installation. Methodology. Flowchart. We have for the start, set PMV parameter and desire PMV. Next is process. PMV will monitor, set monitor, and if this does not achieve, if automatically go to the automatic control and is regulate. If regulate until the PMV is shown in to the LCD, and if yes, it's directly show in the LCD display. This is a block diagram. set PMV is the summing junction. Send signal to change air conditioner output. If error negative, it will decrease the temperature. If error positive, it will be increase the temperature. If error negative, decrease temperature. And PMV will monitor. The LCD will monitor will display the PMV and PMV output. This is formula. This PMV equation. PMV parameter that's used in previous equation. M for metabolic rate, W for effective mechanical power, I CL clothing insulation, F CL clothing surface area factor, TA air temperature, TR mean radial temperature, VA relative air velocity, PA water vapor partial pressure, HC convective heat transfer coefficient, TCL clothing surface temperature. This next, after we calculate the PMV, we must to calculate the power in the power. This is the power equation. COP stand for coefficient of performance. This is a system framework for my project. We have three boxes. Okay, first box is for the humidity sensor, and this board for temperature sensor, and this is main box. All the box is use the wireless. We does not use the wire because it hard to use. Project layout. Bluetooth temperature sensor at the outside of the building. Monitor box must inside of the building. Humidity sensor, Bluetooth humidity sensor also inside of the building. This sensor, temperature sensor, is to measure the temperature outside. This humidity sensor is to measure the humidity inside of the building. Monitor board is to monitor the temperature, humidity, and so on. Is sent signal by wireless. System framework for monitor box. We have LCD. Actually, we use LCD 20 we use LCD 20 times 4 with I2C interface. That is easy to connect. Without I2C, it's hard to connect. This is Arduino keypad, Bluetooth HC05, infrared sensor. This is the microcontroller. We use Arduino Mega 2516. Bluetooth humidity sensor. Humidity sensor, we use the HT22, Arduino Nano FT232, and Bluetooth HC05. Bluetooth temperature sensor, we use temperature sensor DS18B20, Arduino Nano FT232, and Bluetooth HC05. This is a circuit diagram for this project for the FAP1. We in FAP1, the temperature sensor and humidity sensor we have wired. Uh, Actually, for the FAP2, we use the wireless for the uh, temperature sensor and humidity sensor. That is not directly connect to the Mega 2560. This is a system flowchart. Uh, First, start, set metabolism, clothing installation, and BTU. Sensor gathering data, this temperature and humidity sensor. Calculate the PMV and energy. Uh, it will display, and we have the to reset button. Uh, if we set reset, it will continue uh, set metabolism again, and if we doesn't push the reset button, this continue to display and calculate the PMV and energy. This is a list of the component that I will use in my project LCD 20x4 with I2C. It function display the output. Arduino 4x4 metric keypad, one of the most commonly used in input device to set the clothing installation, to select the installation clothing installation, to set the BTU. Bluetooth HC05 connect to the sensor. This is we use three Bluetooth HC05. This for the monitor box, Bluetooth temperature sensor box, and the last one is humidity Bluetooth humidity sensor box. We use two Nano FT232. This controller board. We use one Arduino Mega 2560 macro controller board. We use one humidity sensor DHT22 measure humidity and room temperature. Temperature sensor DS18B20 measure outside temperature. Infrared sensor used to sense certain characteristics surroundings. Project planning. We I have 15 component, and for the last one is for the 3D printing cost. This is the price list, and the total is 386 ringgit. This is expensive because this is the prototype. FAP1 gun shaft. As we can see, we have 70 weeks. Title for project, finalize project, find the research journal, title submission, proposal presentation. For the software development, we have to construct the block diagram, method use, sequence flowchart, finalize the method, testing the method use, device and electrical, finalize circuit for the temperature and humidity sensor, testing the sensor by using the controller, testing the temperature and humidity sensor, collect data, progress check for the FAP1 and 2, submission. This actually for the progress check, we have 2 times. Submission, report FAP1, presentation FAP1, meet with supervisor. We to meet the supervisor every week. This output for the output 1, thermal comfort index and energy consumption measurement device for comfort energy monitoring. Aircon system by using Bluetooth communication. For the output 2, comfort based air conditioning remote control with the comfort energy monitoring system. For the output 1, measurement device for comfort energy monitoring by using Bluetooth communication. Next, I will show is it I achieve or not for the output 1. This is circuit connection that I fabricate for the output 1. For the output 2, we convert the wire of the temperature sensor and humidity sensor to the wireless. This humidity and temperature doesn't connect the Omega. It's connect the nano Arduino Nano, and it's Mega is receive the data by the wireless sensor using the Bluetooth communication. That's a result. Okay, for the output 1, I've developed this project and can monitoring the air temperature this in the uh, Android phone. This is tele as we can see, power consumption 500. Power consumption 500 is the same. It's I'm using the Bluetooth. Disconnect this phone Bluetooth. For the output 1 result, experimental study for effect of TO on TA, RH, and PMV. I run the experiment starting on 9 a.m. until 6 p.m. It's 9 hours I did for the I did on to get this data. Yes, for this is a morning. In this morning, uh, the TO and TA is lower, and for the highest one is a range 12 m 12 a.m. until 3 p.m. This for the red one, red color is for TA. Red color is for the TO, for the outside temperature. This sensor for the to measure the TO or temperature outside is I put the sensor for the outside of my house, and for the blue colors is for the inside temperature is measure in our house. This is data graph for the relative humidity. This is the highest one is range 12 12 nah, 12 until 2 m. The highest one is at the 1 m. This is a decrease until 3 p.m. and it will increase until 4 p.m. And decrease and increase again at 5:30 p.m. This is a relative humidity. This is PMV, predicted mean vote. The highest one. Okay. I will explain. clearly about MV data. Okay, for morning, early morning, this we can see this lowers, and it will increase. It will increase until negative 0.5. This is a power consumption. This result I got during the experiment. We can see the graph. The highest one on at 12 m uh, and for the early morning, you can see is at the lowest and increase until and it decrease at the evening. Okay, this is I have some video to to okay, let me see together. This is my project. This is a Mega Arduino Mega 2560, and this is a Arduino keypad. Arduino keypad. And this keypad function to enter the BTU to select the uh, type of clothes. This is the Bluetooth module HC05. This is a humidity sensor. This is the temperature sensor. This is a waterproof type. This is the connection on the breadboard. We have used two resistor on the first temperature sensor and humidity sensor. Okay, this is the LCD. LCD will display the output. Okay, okay, this is the also the I this is the power bank to supply the power. Actually, in at this time, I'm not using the smartphone. This is a display. This is a Bluetooth. Okay, let me see. If I okay, for example, I select for the number one. See, I'm working the activity. Okay, the hashtag for the enter floating thickness. Okay, for example, I choose one. Okay, enter BTU. Commonly for the aircon is 10,000. I'm sorry, 10,000. This is the display. This is the temperature outside. At this time, I'm not put the sensor at the outside of my house, but I put the same place. Okay, for the last video is I connect the Bluetooth with my smartphone. Okay, this is app for MV and power consumption. Okay, firstly connect the Bluetooth in the smartphone and the HC05. We select HC05 and start monitoring. Let we can see this, for example, power consumption, save the smartphone and LCD display. Okay, okay, that's all